Hello friends, welcome back to our channel Tech India. In this video, we are going to discuss lecture 6th for the series that we have started for DBMS course for exams and placements. So in this video, we will discuss 3 schema architecture of DBMS. So let's start our topic, that is 3 schema architecture of DBMS. 3 schema architecture is also called NC or Spark architecture or 3-level architecture. This framework is used to describe the structure of a specific database system. The 3 schema architecture is also used to separate the user application and physical database. The 3 schema architecture contains 3 levels. It breaks the database down into 3 different categories. The overall design of the database is called database schema. You can see here physical data organization, you can see the database here, then internal level, that is internal schema, then conceptual level, conceptual schema, then external level, that is where user can see the database, view1, view2 and number of user can see. There is no restriction as such. So it will be the architecture, database, then internal level schema, then conceptual schema and then external level, that is the users. Now internal level or internal view. Internal level has an internal schema which describes the physical storage structure of database. The internal schema is also known as physical schema. It uses the physical data model. It is used to define that how the data will be stored in a block. The physical level is used to describe complex low level data structure in detail. Internal view, stored employee record length. So this is the internal view. You can see employee number 4 decimal offset 0, unique e-name, string length 15 offset 4, salary 8, 2 decimal offset 19. So this will be the internal view. Now conceptual level or logical level. The conceptual level schema describes the design of a database at the conceptual level. The conceptual level is also known as logical level. The conceptual schema describes the structure of whole database. The conceptual level describes what data are to be stored in the database and also describes what relationship exists among those data. In the conceptual levels, internal details such as an implementation of data structure are hidden. Programmers and database administrators work at this level. Global view, you can see here employee number integer 4 key, e-name is string, salary is string, debt number is integer, post is string. So this is the global view. And now external level, that is view level. At the external level, a database contains several schemas that sometimes called as sub-schema. The sub-schema is used to describe the different view of the database. An external schema is also known as view schema. Each schema describes the database part that a particular user group is interested and hides the remaining database from that user group. The view schema describes the end user interaction with the database systems. And this is the external view here, you can see. And now data independence. Data independence is a property of database management system by which we can change the database schema at one level of database system without changing the database schema at next higher level. Data independence is one of the main advantage of DBMS. Types of data independence. There are 2 types of data independence, logical data independence and physical data independence. And now data independence in DBMS. So you can see store database, then physical level, conceptual level, external level. So between physical level and conceptual level, it is called physical data independence. And between conceptual level and external level, it is called logical data independence. Now you can see detailed explanation of logical data independence. Changing the logical schema, that is conceptual level, without changing the external schema, that is view level, is called logical data independence. So changing the logical schema, that is conceptual level, that we have discussed here, conceptual level, this is the conceptual level. So changing conceptual level without changing external level is called logical data independence. You can see here, without changing external schema is called logical data independence. Now it is used to keep external schema separate from the logical schema. If we make any changes at the conceptual level of data, it does not affect the view level. This happens at the user interface level. Physical data independence is easy to attain compared to logical data independence. For example, it is possible to add or delete new entities, attributes to the conceptual schema without making changes to the external schema. Now physical data independence. Making changes to physical schema without changing the logical schema is called physical data independence. So if you make any changes in the physical schema and the changes should not be there in the logical schema, that is called physical data independence. If we change the storage size of the database system server, it will not affect the conceptual structure of the database. So this is actually the physical data independence. It is used to keep the conceptual level separate from the internal level. This happens at the logical interface level. It is difficult to attain logical data independence compared to the physical data independence. So logical data independence is difficult to achieve as compared to physical data independence. So basically, if you make changes in the logical data without implementing any change in the view data, it is difficult. But if you make any changes in the database, that is physical system or server you can say, and it should not have any impact in the logical database, that is called physical data independence, and it is easier to achieve. Now example, changing the location of database from C drive to D drive. It is physical data independence. So friends, this was all in this video. Thanks for watching this video and have a great learning.